Hey, I'm Rob. In this video today, I'm going to talk about building two different drums. The first drum was a bit of a failure. I tried some new techniques on it and I love the design, but the execution was poor between some things I did in toolpaths and the machine itself. It didn't turn out right. But the other drum, this one, I am very happy with. Maybe my best ever. We'll see. We can talk about that later in the video. For those of you who've been waiting for a video contently and for a long time, I'm sorry. Life gets in the way sometimes. I have a full-time job. I have family. We've taken multiple trips over the past few months, and we've got another trip next month again. Very busy time for us. And plus, it's Arizona outside, and it's hot. And it will be for the next several months. My workshop time is limited to early mornings on the weekends before it gets too hot out in the garage. So don't expect a lot of videos again for the next few months. I might try to do a few smaller projects, but big projects, probably not going to happen. Let's head on over to VCarve Pro and look at how I designed these and talk about the differences between the two drums. In the opening, I mentioned I did two drums for this project. The first one was a failure, and the next one came out very well. First, let's talk about the failure. For that one, again, I'm using VCarve Pro for both projects. For this one, I'm using a different kind of toolpath that I'd never used before, which in theory should be better, but in actuality, it didn't work out very well. I'm using, for the finishing 3D toolpath, I'm using two bits, a 1/4-inch ball nose and a 16-inch taper ball nose. It's a Skinny Jenny from Cadence. I've sang his praises before. I still feel those are some of the best bits on the market, and a little more expensive, but a lot better, a lot more durability. I'm very happy with them. I'll keep supporting him very strongly. Anyway, back to this. I'm using two bits for this. That's called rest machining when you use the two bits like that. Your first thought is like this is a roughing toolpath, and that's not what it is. This first toolpath, it does the low definition first, and then it will do the high definition later. Since I do a lot of talking on this, and then I have videos, there's not much to say about it. I'm going to run the video up in the corner here, so let's watch the videos. I'll try to do the toolpath for this first drum with that one, and then when I talk about the other drum, I will show the toolpath for that one. So first is a 1/4-inch ball nose. Let's run that. And again, this is kind of slow rendering, so I won't talk during this, and I'll speed it up. The definition is okay on this. You can certainly tell it's a dragon, but once I do the full taper ball nose, it'll be much better definition. Let's go ahead and just show that. This explains how the rest machining works better. The spots where like these scales aren't high def, they're relatively smooth, aren't that deep, sharp edges, the 1/4-inch ball nose should do fine. And then once we zoom in, we can see that the little 16-inch taper ball nose really gets those nooks and crannies much better. So I'm going to undo this. So you can see that picture right there of the dragon. I'm going to run this to run that toolpath, and you can see, oops, wrong one. Run this one, and we'll see how much better the definition will be. So I'll probably copy the screen here, and then I'll run this and then show still the other one. So I'm going to preview the other one now. Again, very slow, so you won't hear me talking for a while. So as you can see, like these scales, much better definition here, and the face and the eyes and even like the eyeballs comes out much better now. So in theory, this should be a lot faster. Let's pull up the two toolpaths, and I'm going to hit clock here. It says 4 hours 52 minutes for the 1/4-inch and 3 hours 20 minutes for the 16-inch. VCarve Pro tries to guesstimate how fast it's going to be, and on my settings, I usually beat these speeds by quite a bit. It's the more definition there is, the better mine does against those times. We can talk about it, but I have theories on how this estimating time works. It normally is, I can guess pretty close from that how long it's going to take. In this case, I was way wrong. The 1/4-inch ball nose, I beat that. And actually I had the setting set on that one a little different. My thought, which was incorrect, is that a bigger bit, I don't need to have as tight a step over. So I was running 10 or 12%. So it said 3.5 hours when I ran it. That is not correct. You still need to have 8% step over or less to get a good finish. And so, yeah, you learn from my mistake. There were other issues with this drum. It wasn't going to work. I knew early on that it was a test drum, so no big deal. Now, the other part, this says 3 hours, 22 minutes for that. So when I first did this, I thought I could have a good 3D drum finished in 6 hours. I usually beat these numbers. So I thought maybe 6 hours I could have a good 3D drum. And I was kind of excited this might work. Problems. First of all, the tapered ball nose one, I ran 5, 6 hours, and it was only half done. So it guessed completely wrong on the speed on that one. Completely wrong. And after we run this, I'll unclick that. You can see these little tooling lines where it goes between bits. I had those big time. And I'd even raised the bit a little bit ahead of time, thinking I will go a little high, then creep down to the right setting to get a good finish and not show those. I had those even a higher Z height. So I don't think this is the right tool path strategy for me. Maybe somebody else it works for, but I had bad luck with it. When I go to the other one, we'll see that the hours were a long time, 21 hours. I sped the speed up to 150%, and I got less than 10 hours. And the more I think about it, I could have sped up more yet. I could have got it down to probably 8 hours. So suddenly, the non-rest machining toolpath is faster and better definition. So you see here these scales, that's where it didn't cut for the tapered ball nose. Even those areas, it looks better with the 16th ball nose. I'll come back to that in a second, but I'll probably cut and paste a picture. We'll show both of them side by side. But this definition is very good through here where it needed it. But these other areas where the 1/4 inch ball nose did it, not as good. Let's go ahead and go to the other one I have for VCarve Pro. This is the newer version. Let's go here. I'm going to reset. We'll run that one again. Again, it will be slow, so I will stop talking and speed up the toolpath here. So now that that's done, the definition on this area is probably equal as far as a 3D rendering, but no telltale lines, switching tools. Again, even that eyeball, that just impressed me so much. I'll show a picture later of the actual drum, just around the eyes and the teeth and all these little things. Came out so good. As far as executing a 3D toolpath, this is probably the best one I've ever done on my rotary machine doing a drum. I'm not saying it's my best design, though I do really like this design. It might be my best design, but actually executing, cutting out the drum, this is probably the best one I've ever done. I am really happy with this design, or really happy with this finished product. So let's talk about the toolpath now, how it's different. Again, I just use a single tool bed, 16-inch tapered ball nose. My settings, I believe, were 8% step over. The whole thing just came out so good. I am very happy with that. Even little things like this area right here, which doesn't look major, it's just a little kind of wavy background. It came out so good that I didn't have to do any sanding. I shouldn't say any sanding. I touched up a few little specks and some fuzzies. There were fuzzies. You always get some fuzzies, but I put in a few minutes of cleaning up some edges like that instead of past drums hours. And when I got talking about the issues I had on the machine on this one, also the original drum, I had some machine issues, and I could have sanded out those issues. Would have taken many hours, and plus you can sand out these flat areas, but when there's issues on the actual 3D design, you can't sand out an issue there. So it just, you can't. It's so detailed that you can't get in there and do it right. So this drum, again, it took 10 hours to cut that 3D design, but the prep work for finishing after that was minuscule, much faster than normal. I got the things dialed in just right now. So I'm very happy with that. was talking about the speeds and feeds and how long it would take to cut on the other drum. On this, the second drum, let's take a look at what it estimates the time for this one. So 20 hours, 53 minutes, 21 hours basically. And this one, even without changing the speeds up my machine, it'll do that in much, much less time. Probably 11 to 12 hours if I leave it at 100% normal speed. For the drum I cut, I took it to 150%, which is 150 inches per minute. If we look at the settings on that one, it's set for 100. Plunge rate, feed rate, 100, 100. At 150, so it basically increased it to 150 inches per minute. And there'd be no problem punching that up to 200% at the machine. I could get it down a little lower, like I said. Two things to touch on that. When you're doing a 3D cut, let's zoom in on this. You can see this line going up and down. What it's actually cutting is this line up and down like that. It's taking off basically 5 thou each pass. So very, very little wood is actually coming off each pass. That's why, even though you have a tapered ball nose with a 16-inch end on that, very fine, delicate, you're only taking off 5 thou, 8% of that little bit. So you can push it very hard and not worry about the bit. Now, deep plunges in certain situations, which this one doesn't have, but occasionally if you have a sudden drop off, you're cutting a very deep cut with that 1/8 inch 100% instead of 8%. If you have a sudden hole pocket that's going through, I don't have anything like this one. So it's not a worry for me on this cut, but something you should be a little worried about or conscious of, at least if you're doing cuts like this. But for this scenario, I crank it up to 200% and not worry about damaging the bit or hurting the cut. I mentioned before, my machine, every machine's got a setup for the acceleration, deceleration. So you're going through these areas, it's not going to go 200 inches per minute, all these jagged areas anyway. It's this, these long straightaways. Let me turn that back off. This straight area through here, it will reach 200 inches per minute. And like through here and all this very little changes, it'll zoom through that nearly 200 inches per minute. Then you get to the changes, this area much slower and the face much slower yet, all these things here. So I push 200 inches per minute on that machine all the time, no issues. And like I said, I can probably get down to 8 hours if I push it really hard. So here are some pictures of that first drum that were the failure. As you can see these lines up and down. That's why I had too high of a step over set for that 1/4 inch ball nose. I think I had a 12% step over. Right? In my mind, I thought I could get a better equal finish with a higher step over the bigger bit. That just was totally wrong. The definition, even through these other areas, which you can't see, but this is before I did the taper ball nose, the second pass. So let's look at that one. It's got a much better finish for these tight areas. You can see these are the scales here, there's big scales there, the facial features. Just much, much better. But you can also see those tooling marks I mentioned before also. The tooling marks where it goes between the tools, these lines here, totally unacceptable. Yes, I could technically sand those out. Oh, hours and hours of work. And I don't like sanding. I mean, I know it's a necessary evil. I will do it for certain things, but wow, so much more work here. I go to the other drum. Here we can see that drum. The second drum I did. Again, very little sanding done here, and the finish is top notch. Part of that's the machine getting dialed in, and part of that's the, I'll give some credit to that Skinny Jenny 16-inch tapered ball nose from Caton's Manufacturing. This came out so good. The other thing I was having issues with the machine. See these issues right here where on the edges, you can see it in a few other spots. You can probably see it right here, down here and stuff. I was having issues with my machine. And the last drum I did, I was having somewhat issues like this, but this is even worse yet. I was trying to figure out the problem was. I was suspecting that it was the backlash nut was getting loose and I was getting issues there. I took the nut off and it appeared fine, but once it was off, when I could slide the X plate back and forth in the gantry, I realized it was binding. There was dirt or some kind of issues in the linear rails. Once I cleaned that out, blew it out real good with the air hose, cleaned up what I could, Put some oil back in there again. Wow, world of difference. So between the wrong toolpath and the machine issues, this drum was a complete failure. But the next one, wow, it came out so good. Very happy what happened in the end. I'll show some more pictures later. I'm going to start out showing the carving of the drum. I know before I had the upper corner, I was showing the 3D toolpath, but that was late in the process. I'll start from the beginning here. The first step is to do the epoxy for the logos. The first little thing I did was carved a pocket around where the logo is going to be. That way I can fill it up with epoxy later without it spilling over the drum. I'm using a 60-degree groovy Jenny on this to cut the logo out. I did the same thing on the other side of the drum to show the text, but I figured it's kind of redundant to show the same thing twice. So we'll just look at this side. One of the tricks I like to use is I'll run the toolpath twice. That helps clean up any little fuzzies in there. It's kind of a big deal not to spend a lot of time trying to get little specks out there and get a clean finish. It's so detailed, it's easy to knock off pieces, ruin things. So the toolpath is so exact that it cleans it up very nice, and there's very little cleanup for me to do before I pour the epoxy. For pouring the epoxy, I'm using just a basic 30-minute epoxy. It's pretty quick curing, and I just have black dye in it. If I was doing something more detailed or advanced, I wouldn't use a 30-minute cure. I'd want something that takes a little longer. If I had effects, I would also want something longer, but for basic black, just filling in some carves, this works fine. For those of you with an eagle eye attention to detail, I had a phone call in the middle of this pour, so that's why I started with a blue glove on my hand and I ended up without a blue glove. For skimming the outside of the drum to get it nice and round, I'm using a 1-inch surfacing bit I got from IDC Woodcraft. I do like this bit quite a bit. It does a good job for surfacing. And for the inside of the drum, which I'm not going to show, I used a 3/4-inch ball nose I got from IDC Woodcraft. Again, another great company that supports the hobbyist, and I like both IDC and Cadence a lot. I already showed the 3D toolpath in that tiny window when I was in VCarve Pro, but I'll show the whole thing on a bigger screen right here, sped way up. This took 10 hours total. Like I said before, if I speed up the inches per minute, I could probably get this down to 8 hours. There's a common misconception in the CNC community, with beginners especially, that if you double the inches per minute, you'll cut in half the time it takes to carve a project. That's not correct, especially on a 3D project where there's lots of starting and stopping and slowing down and changing direction. That only really affects the top end speed when it's going full blast on a straightaway, but you rarely do that on a 3D project. You only decrease the cut time a little bit on a 3D project by doubling the inches per minute when you're cutting. For the bearing edge, or the rounded edge on the top and bottom of the drum, I'm using a molding toolpath with a 1/4-inch ball nose. There's 3 parts to the toolpath I have. First, I make a pocket that cuts deep enough so when it does a rounding toolpath or the molding toolpath, it won't take too big of a cut. Then it does the actual molding rounded edge. And then last of all, it cuts pockets around that, so it leaves tabs holding everything together. Much easier in the end to cut through those tabs instead of cut the whole thing out. At this point, I will take the drum off the CNC, cut through those tabs with a jigsaw, and then go over the router table with a flush trim bit and get rid of those tabs. I'm not going to show the internal carving of the drum, the smoothing of the inside, because the video didn't turn out very well, and I've shown it before, and I'll probably show it again later in the future. In the past, I've had people ask about the jig I use for finishing the drums. So this is what I call the spider. It's on a threaded rod. As I tighten the bolts, the arms or legs of the spider expand out, holding the drum nice and firm. It spins freely on that threaded rod, and it works really well. I originally built this to actually work on the CNC machine, and it didn't work for that, but I later found it works awesome for finishing the drums. I always like doing the video where I put the finish on. It just shows how it pops. The colors really show up better. The 3D shape pulls up better. For finish, I'm using General Finishes Armor Seal. It's a wipe on. I like the results with this, but I don't like how much time it takes. To get a good finish, I have to build up many layers. I do 4 layers, sand it, a very light sanding, or even with just the 3M pads. And I'll do it again, 4 more layers, 3M pads, and possibly one more time. So there's up to 12 layers on this. It's oil-based, it takes a while to dry. I love the results, but it's very time consuming. I've been playing with lacquer and I'm having good results with that. The one issue I have with lacquer is it doesn't penetrate like this because this takes, again, several hours to dry, to soak in and finish, whereas lacquer dries in only a few minutes. It doesn't soak in. I'll probably try using something that soaks in first, like a Danish oil, maybe even Danish oil with some coloring to get a little darker, and then let that dry completely, lacquer on top. So that'll probably be next when I try. I can't argue the results with the General Finishes Armor Seal wipe on. I'm going to finish up with some beauty shots of the drum. First, I'll spin it around to 360 so you can see the whole thing. And then I'll do a few individual shots. Some of these shots have hardware and some are just a shell. My favorite one is this final shot of the drum with the face. I mentioned before the details on the face, even down to the eyeball. It is amazing the detail I got on this drum. I am so happy with it. Once again, I have to say, this is the best execution of cutting a drum design out I think I've done so far. If you enjoyed this video, please consider giving me a like and subscribe to the channel, and everyone have a great day.